Okay, so now let's talk about multiplication and division of radical expressions. And again, we're back to using our multiplication and division rules as illustrated in a few of our earlier examples. Only this time, we're given a product already, and we need to combine it somehow. Well, I think there are some things that are indicated right away. For example, let's take on this expression right here, where we have the cube root of 4 times the cube root of 16. And we should probably multiply together these two things. We would notice, for example, that if we took the cube root of 4 times 16, 4 times 16 is already a perfect cube, right? It is the cube root of 64. And we know that cube root, right? That's just equal to 4. Now, how did it come out to be 4 like that? Well, one thing that I should note is that 16 is equal to 4 squared, right? And so if you really think about the situation, it's like we've got the cube root of 4 raised to the first power times the cube root of 4 raised to the second power. And so by this rule, this is like saying the cube root of 4 to the third power. And if you think about it in those terms, it's no wonder that we get 4 as a result. So sometimes that kind of thinking is really, really helpful. Like, for example, in this case, we've got 3, we've got 27 under square roots. We're looking for perfect squares. Well, you might recognize that 3 times 27 is 81. Right? So we've got the square root of 3xy times 27xy squared. And if we multiply these things together, we have a cube root of 3 times 27, which is 81, x times x, which is x squared, and y times y squared. Now, I'm not multiplying those two together for a reason, because I'm looking for perfect square factors. And I notice that 81 is a perfect square of 9. X squared is a perfect square of x. Again, we're assuming that we've got only positive numbers here. And y is a perfect square of y squared. So the square root that's left over is just the factor of y, and this is now a simplified radical expression in this case, 9xy times the square root of y. All right, this one looks a little bit more drawn out and complex, but actually, again, not that bad. One thing I should note for you, when we combine all of these things under the fourth root, 27 is already 3 cubed. And we've got a squared, we've got b cubed, we've got 3 to the first, we've got a to the sixth, and we've got b to the fifth. Now remember that when it comes to exponents, addition is always the case. So it's like saying we've got the fourth root of 3 to the fourth power when we combine these two guys together. A squared times a to the sixth gives us a to the eighth, and 8 is divisible by 4. And b to the third times b to the fifth is b to the eighth as well, and that's also divisible by 4. So you might recognize that all of these are perfect fourth power factors. And so we've got 3 to the fourth, which factors as 3 after that comes out of the fourth root. The fourth root of a to the eighth, which is a squared. And the fourth root of b to the eighth, which is b squared as well. If you have trouble picturing those last ones, let me just quickly just shunt off to the side here with a quick note. If we take the fourth root of a to the eighth, right, recall that means a to the 8/4 power, and 8 over 4 reduces as a squared. So in fact, that's really good for us. Okay, next one right here. We have some more fraction multiplication that we can do, but we'll come back to that in the next video.